Welcome to today's math lesson on an introduction to Pythagorean Theorem problems. Our do now reads the amount of money Miss Huang earns varies directly with the number of hours she works. So my two factors are the amount of money and the number of hours. So the time is going to be my independent variable represented by x, and the amount of money is going to be my dependent variable since the amount of money depends on the time worked. And if I earn $300 for working 20 hours, how much will Ms. Huang earn in 45 hours? So there's several ways to solve this. You can make a proportion, you can divide and multiply, but I'm going to start off making the woe chart. So my W stands for words, and in this case, they're going to represent the units in the problem, which is going to be money and hours. And then I'm going to fill in my O column, which is just going to be the original numbers given. So I have $300 for 20 hours. And then I have to fill in my E column for equivalent. And that's going to be the 45 hours is going to go on the bottom. And since I'm trying to find the amount of money I made, X is going to go on top. So from this woe chart, I can make my proportion. I have 300 over 20, then I have x over 45. I'm going to cross multiply and divide or do the butterfly method. So I have 20 times x, which is 20x. Then I have 300 times 45, which is 13,500. And then I have to get the x alone, and so I'm going to divide both sides by 20. (20) divided by 20 is 1, so we have x is equal to, then we have 13,500 divided by 20, and that's going to be 625. My mistake, it's actually going to be 675. And so X represents the dollar, so I have to be sure to include the unit. So in 45 hours, I made $675. Today's TEK is 8.6C, and our lesson target is scholars will use diagrams to explain the Pythagorean theorem. And our DOL is given 3 problems. Scholars will use diagrams to explain the Pythagorean theorem with 100% accuracy. So we have some new vocabulary words. We have hypotenuse, and the hypotenuse is going to be the longest side length of a right triangle. And so it's this purple side right here. The legs of a right triangle are going to be the height and the base. As you can see in this corner right here, we have a right angle. And so a right triangle has a right angle. We have the Pythagorean theorem equation, which is a squared plus b squared is equal to c squared. So the height is always going to be a. And so if we multiply a times a plus b times b, whatever that length is, it should be equal to c times c. And we're going to get more into that in today's lesson. And so we're going to need to square root to sometimes solve for the side length if we know the area. This first IG problem says the diagram is showing 3 squares. Those squares form a right triangle. What is the area of the third square? So I'm just going to go ahead and draw the inside triangle that it forms, or just at least outline it so that it's more clear. So this is the right triangle. And so we have to find the area of this third square, by the third square meaning the yellow square. So if this side length is 21, since it's a square, I know that this side length is also 21 centimeters. 21 times 21 is 441. And when I multiply centimeters times centimeters, I get centimeters squared. So that is my answer to the second question. But let's say I want to figure out the side lengths of this leg right here, or the height of the right triangle as well as the hypotenuse. I'm given the area. So this area basically means that this side length times this side length is 400. And so I'm going to try to find the square root, which is the same thing as thinking of what number times itself is equal to 400. And the square root of 400 is 20. So that means that this height of the right triangle is 20 centimeters. Then I'm going to use that same thinking to find the length of the hypotenuse. I know that the area of the triangle that is formed by the hypotenuse is 841 centimeters square. So I'm going to find the square root of 841. And that is 29. So that means that the length of the hypotenuse is 29 centimeters. So again, when I have the side length and I'm trying to find the area, I just multiply that number by itself. So in this case, I had the side length is 21. To find the area, I'm doing 21 times 21. When I'm trying to find the opposite, when I have the area, but I'm trying to find the side length, I have to think of the square root. So the biggest mistake is that people divide it by 2, and that's not correct, because 400 divided by 2 is 200, and the side length is definitely not 200 centimeters. So you have to think of what number times itself is equal to that number. And that's also the same thing as square rooting that number. This next I do problem reads, the squares to the right form a right triangle. We have to write an equation showing this relationship, and then we have to answer the question, what is the length of x? So I'm going to make the right triangle that's formed by these squares a little bit more clear. So it's right here, and then of course it's also drawn right here. So we know that the Pythagorean Theorem equation is a square plus b square is equal to c square. And so this is just one of the equations that you're going to have to memorize. And we have to remind ourselves that this height is always going to be our a value, and that this base length is always going to be our b value, making our hypotenuse always our c value. So what we're going to do now is plug in all those numbers into this equation. So we have 9 squared plus b squared, or x squared, is equal to 15 squared. So to figure out the length of x, we have the area, 144 centimeters square. To find the side length, I'm going to have to square root it. So the square root of 144 is 12 centimeters. So that answers the second question, because 12 times 12 makes 144. So that means that the side length, x, is 12. But if I wanted to find the areas of this orange triangle as well as this purple triangle, I would multiply 9 times 9, or find 9 square. 9 square is 81. And because it's 9 centimeters times 9 centimeters, it's 81 centimeters squared. Then over here I have 15 times 15, which is 225 centimeters squared. So when we're given the area and we're trying to find the side length, we have to square root. But if we're given the side length and we want to find the area, we have to square. And so an example is 3 square is not 3 times 2, it's 3 times 3, which is 9. But let's say we wanted to find the square root of 9. We would have to write the square root symbol on both sides, because whatever we do to one side, we do to the other. So the square root of 9 is basically the thinking, what number times itself is equal to 9? And we already know that's 3, right? But on this left side right here, we have the square root symbol as well as the square symbol. And we just have to know that when we have those two together, they cross out. So we're just left with 3 is equal to the square root of 9. So just to clarify, this equation right here is the same thing as saying that the area of this smaller square plus the area of the medium-sized square, so the two smaller squares areas added together makes the area of the largest square. Because a squared is a times a, which gives us the area of this blue square. B squared is b times b, which gives us the area of this green square. And when we add these two together, it needs to be equal to the area of this red square, the largest square, since the hypotenuse is the longest side on the right triangle. So now it's time to complete the Google form DOL. Thank you so much for following along and paying attention in today's math lesson, and see you in the next math video. Bye.